We've completed the PHET simulation that tells us what happens to the force of gravity as we change the size of the different masses involved in the force of attraction and change the separation as well. We went on and developed a proportionality statement, and we filled in our table of values to find out what the relationship looks like from a tables of values standpoint between the combined proportionality statement and the size of the force of attraction between the two objects. Our next job is to try and find what is known as the proportionality constant, which in this case is referred to as big G. This is the tool we are going to use. We are going to use the Desmos embedded file called Finding G. The first value is already put in for you, and so when you take m1, multiply it by m2, and divide it by the r squared, the separation, this is the value you get. And as you can see, Desmos has plotted this down here. Hopefully we are going to get a nice straight line, in which case we can look for a relationship and a proportionality constant, which is known as big G. Here is how you enter it, because it is a little bit tricky. You will notice that our independent variable x1, which is m1, m2 divided by r squared, is in the first column, and it's labeled x1. That's the big point. And our dependent y1 is in the second column. You're going to fill in the rest of the values in this table, and when you're done, you're going to ask Desmos to make a proportionality statement. This is how you do it. Y, and we need to know that it's y sub 1. Now, what we have to do is hit the right arrow key on your number pad, and instead of an equals we use a tilde, and our proportionality constant is G, and the variable, the independent variable, is X, and I have to hit the underscore, which is in the sort of on the top right of the keyboard, 1, just like before. And what Desmos tries to do is do a linear regression and give us a value for big G, which is the constant due to gravity.